Okay, now for this rule, question 1, so we're going to go through last year's linear test. What is the value of y when x equals -1? What are we doing here? Yeah.
We're substituting -1
into the equation.
-2 minus 5 7. B.
Okay, so y is equal to 2 times -1 minus 5, which is equal to 2 times -1, which is -2 minus 5, which is equal to -7.
Yeah.
Very good. Okay. Now, what I do need to do though, which of the following rules has a gradient of -3 and a y-intercept of 0, 1?
1.
So therefore we've got y is equal to -3x and a gradient of 1 would be +1. Is that any of those there?
Nope. Nope.
No, it's not. However, if we rearrange one of these, which one of these rearranged could give you this? Well, if I add one, if I look at A, if I subtract 3x from both sides and add 1 to both sides, that's going to give me y is equal to that one. So the answer is A. So let's have a look at this one.
It's not, sir, because it's minus
B,
1.
sir.
That's some electricity, sir. Let's go for your hand.
Oh, no.
Yeah, but
that's right.
if I add 3x to both sides, if I subtract 3x to both sides, that's going to give me y is equal to... Shh, thank you. It's really hard to concentrate. Like that. And then I want to add 1 to both sides. That's going to give me -3x plus 1. And that's what we've got here. So the answer is A. We're just rearranging that, Michael. Oh.
What do you want?
Alright, the gradient between 2 points is -2. What is the value of the... Well, first of all, if it's -2, then -2 has to equal rise over run. And what is the rise? Isn't it, if this, we're going to have this point here as point 2, we'll call this x2, y2, and this point here will be x1, y1. So what we've got is we're going to call that y2. So y2 minus 4 over, what have we got there? We've got 2 minus 1. So I've got an equation, -2 is equal to y2 minus 4 over 1. What would y2 have to be equal to? What do I do to both sides to solve for this equation? What would you do? Jake? Yeah. Plus 4 to both sides, good. So y2 is equal to -2 plus 4 is equal to 2. And that's all we need to do. Now you could have done it by trial and error. If you pumped each of these values into there, you would have eventually seen that -1 minus 4, if I tried this value, that's not going to give me the answer that I need. And you could have actually done trial and error as well. Okay, so the answer there is D. The graphs of, we're not really given much room here, however, this is a bit annoying. The graphs of x equals 1 and y equals -3 intersect at a point. Well, what does a graph of x equal 1 look like? It's going to be a vertical line. X equals 1. Y equals -3. Could be this line here. What point are they going to intersect? Aren't they going to intersect at this point here? And what's the coordinates at that point? What comes first before in the alphabet? 1, -3. So they're going to intersect at the point 1, -3. So the answer is A.
What's the difference between just looking at those x and y and just putting it there?
Well, you need to understand what the graphs look like. The graph of x equals 1 is a vertical line, and the graph, and then we're going to do intersections and simultaneous equations next. But the graph of y equals -3 is a horizontal line. So of course the only point they could intersect is at those points. So no, we don't even have maths tomorrow. All right, now we'll push through the multiple choice. Let's just skip that one for the time being. A cyclist travels at 20 kilometres an hour in 30 minutes. What is their speed? If you think about their speed, kilometres per hour. Unit, what unit is kilometres? Isn't it a distance? And what unit is hours? Isn't it time? So speed is actually distance over time. So a cyclist travels 20 kilometres distance in 30 minutes, but let's change that 30 minutes to hours. So we've got 20 kilometres into half an hour. And if I did 20 divided by a half, I'm going to get 40. So the answer would be 40 kilometres per hour. Which makes sense, because if they travel 20 kilometres in 30 minutes, they would travel 40 kilometres in 1 hour.
So the test could be similar to this.
It would be fairly similar. Well, are you finding it hard, easy?
No.
It's fine? Okay. All right, now let's have a look at finding gradients. So now we've got room, thank Christ. Now, what points, I might just go over. Zach, can you explain to me how you would find the gradient of part A? What would you do?
Just rise over run.
Rise over run. Okay, so tell me, how much is it rising?
3.
So it's rising 3, and the run is?
I think 2.
Yep. So this one's a pretty straightforward, easy one. Just by looking at the graph, we can see that it rises 3 and goes... No. No. You can't have negative run. You can have negative rise. Over here, though, however, Jake, we have a run. The rise is -6 and the run is 4. And of course, we can simplify that fraction by dividing both sides by 2. So we have the same gradient for part B, but it is negative. You can always, if you get a negative gradient, make sure that you have a look at the graph again and make sure that it is sloping downwards. Okay? Because if it isn't, if you get a positive gradient and it's sloping downwards, you know you've made a mistake, and usually it's a problem. Yes, mate. Yes. This is your last period before the test, that's correct. All right, write the equation of the line that has a gradient of -2 and a y-intercept of -3. So is this a pretty straightforward problem? Yeah? Y is equal to mx plus c. Tennyson, can you please tell me what does the m mean?
M is the gradient.
M is the gradient, yep. And
C is the y-intercept.
Okay, good. And it's very important. You need to know that y is equal to -2x plus, well, I guess technically it's plus -3, which is -2x minus 3. All right, now what are the gradient and y-intercept of the graph of this? What do I have to do? What do you have to do, Peter, before we can tell what the gradient and the y-intercept
We
are?
have to leave y by itself.
Yep.
So divide 2y by 2.
Did you want to just do the working here?
Alright.
You can have a go.
Alright, so...
Explain what you're doing.
Okay, so that's the equation. And you'll divide this by 2, because you want y by itself, which means you'll divide that by 2.
Okay, good.
And then that would give you 2x minus a half.
Okay.
And then it's asking what are the gradients and y-intercepts. Well, y equals mx plus c, so m is 2 in this case, so the gradient is 2.
Beautiful.
And c is the y-intercept, so that would mean that the y-intercept equals -1/2.
Good. Awesome. Is everyone okay with that? Yeah. Good. All right. Now, sketching some graphs. Well, First of all, if you think about the y coordinate being negative 4, if I had a y-intercept of negative 4, well, all the values are negative 4. So that means that's a horizontal line. A lot of students mess that up for some reason. I guess because they're used to doing straight lines which have a gradient. Can someone tell me what is the slope of that graph? What is the slope of that graph, or the gradient? 0. Good. What about this graph here? If I have x equals 3, undefined. Because there's no run. So if I had a rise... Ooh. It's not ideal. I'd rather do this in OneNote, but it was not working. So if I have rise over run, it has an infinite amount of rise, and the run is 0. So if you try to do anything divided by 0 in your calculator... Now, what about y equals minus x? Quite a few students were asking me about that. Well, first of all, plus 0 is, I guess, 0 is the y-intercept. So that means that it must go through the origin. And if it goes through the origin, and it has a negative gradient, it has to look like this. Actually, a graph which goes through the origin. All right, so any constant, if there's no constant... If we've just got negative x, or it could be y. What about if I had y equals 3x? Y equals 3x is also going to go through the origin. Yeah.
For y equals 3x, would you sum in a point, like say 1, and then you find the other 4?
Look, I guess the thing about y equals 3x is I haven't really sketched it properly there, have I? Because it's going to have a higher gradient, isn't it? So y equals 3x is going to look something like this. Okay, so you can see there that this gradient has about 3 times the gradient of the other. So, exactly 3 times the gradient, just in the other direction.
So it could be anywhere.
Yeah.
Would you get it right if you got that?
Yeah, that's fine.
And if you went the other way, would you get that right as well?
No. Has to be the right way.
There's 2 x's.
Huh?
Why are there 2 x's?
No, I just was showing something. Okay, so the last one, we have to divide both sides by 2. We have to isolate y. So I'm dividing both sides by 2. And that's going to give me y is equal to 3x, or 3 over 2x, plus 3. And that is going to give me a y-intercept of 3. And showing the x and the y-intercepts. Now, in the previous ones, fairly straightforward, but how do we find the x-intercept? What do we do? Does anyone put their hand up? Anyone else? Maggie, how do you find the x-intercept?
Is it just the coefficient of the x?
No, that's the gradient. What can you tell me? What does y equal here? What does y equal here? What does y equal?
I got a different answer.
The y-intercept's 3. But what does y equal at the point where it crosses the x-axis? 0. So what we need to do is to find the x-intercept, we have to let y equal 0. To find the y-intercept, we actually have to let x equal 0. So what we do is we go x-intercept. We might need to do a little bit of working. Let y equal 0. And what we have to do is solve for x. What was that, sorry? Yeah, absolutely. And we did that in our exercises, finding the x and y intercepts. The y intercept's a lot easier. So now what we need to do is rearrange, and we need to isolate x. So I'm going to subtract 3 from both sides. I've got negative 3 is equal to 3 over 2x. And then I'm going to do a couple of things. I could do I could divide through both sides by 3, but I'm going to just multiply this left side by 2, do the same there, and that's going to cancel that out. So we've got minus 6 is equal to 3x, and you should then see that dividing both sides by 3, x is equal to minus 3, isn't it? Oh, dividing minus 2. All right, so what we have is we have this. No, we want to go to that. So we have a line, and that is minus 2 for the x-intercept. All right, let's persist. Find the equation of the line which has a gradient of minus 2 and passes through the point. Now, whenever you're doing this, I'd never want to see this blank, because a gradient of minus 2, we should all know that y equals mx plus c. We know that m is equal to minus 2. Now, in order to find the equation of a line, we need two pieces of information. We either need the gradient, or we need a gradient and a point, or we could have 2 points. Either way, you need two pieces of information. You need 2 points, basically. But by being given the gradient, that actually means that we can go ahead and say that, where is it? Well, m, we now know. Now, x is variable, and the last thing we need to do to find the equation is c. So what we're going to do then is, now we know that the m is minus 2, we're going to just, that's pretty much taken us halfway there. So what we're going to do is get the pen out, and we're going to say that y is equal to minus 2x plus c. You may think that there's 1, 2, 3 unknowns, but y and x are variables. So, and we're actually given those variables, so we've only got one unknown, which is c. So what we're going to do is we're going to sub this point in to this equation here. So when x equals negative 1, y is equal to 4. So we're going to write that in. So we've got 4 is equal to negative 2 times whatever the x value is, minus 1, plus c. You're going to notice there that we've just got one unknown now. We've just got c, and then we've found the equation. So we've got 4 is equal to negative 2 times negative 1 is 2 plus c. We're going to subtract 2 from both sides, so c is going to be equal to 2. So therefore, our equation is y equals negative 2x plus 2. In terms of marks, how would we mark that? Well, I would probably say that let's sort of get a marking scheme going here. I would say that just identifying that m is equal to minus 2 in the equation is going to give you 1 mark. Then subbing it in will get you a 2nd mark, and stating the equation in full will give you a 3rd mark. Okay? So this time, what are we given for question 11? Aren't we given, how many pieces of information are we given? We're given 2. Now, you could do it a number of ways, but I'm going to show you what I think would probably be the easiest way. First of all, find the gradient, which is equal to rise over run, or if you like, now which one's the first point? This is the first point, x1, y1, x2, y2. So I'm going to say that that's y2 minus y1 over x2 minus x1. What do you know, though, as the point goes across? Is the y coordinate going up or down? If I go from x1 to x2, is it going to have a positive gradient or a negative gradient? Is it? Well, let's think about the point 0, negative 4. Point 0, negative 4 might be down here. The point 6 minus 2, yeah, the point 6 minus 2 is actually going to be, say, here. So sometimes it helps you to identify if those points, if we're going across, that means it has to be a positive gradient, doesn't it? All right, because sometimes we can mess that up. So what we're going to do is we've got minus 2. Be careful with your negatives here. Negative minus 4. Okay? Over x2, which is 6 minus 0. So what we've got is we've got minus 2. Two negatives are going to cancel out to give us positive 4 over 6, which is equal to 2 over 6, which is equal to a third. So what we've got is we've got y equals to a third x plus c. Now you could use either of these. However, I think that the best one to use, what can you tell me about, well, isn't this giving me the y-intercept, this thing here? 0, negative 4?
Yeah.
So therefore c is equal to negative 4.
Yeah.
Now you're not always going to be given the y-intercept, however. So that's just made our life a little bit easier.
I didn't even figure that out.
Yeah. So, it's a bit of a mess here. Alright, which is equal to 1/3 x. What is going on? Plus c.
It was like highlighting
Yeah,
everything.
just click out of it.
Okay.
It is still whack.
Now, determine the equation of the following straight line.
That's what I think so.
Alright. So how do we determine the equation? Does anyone want to... Tristan, how do you determine the equation of this straight line?
Well, you get the 2 points, which the first point is minus 2, 0.
Yep.
That's
Okay, good. Shh. So Tristan's saying that the point that he's got is minus 2, 0. That's one piece of information. Good. And the other point?
which is 0 minus 3.
0 minus 3. All right. Now, Tristan, what can you tell us about what have we been given automatically in y equals mx plus c?
We've been given c, the second point.
So you've been given that c is equal to negative 3. Is that correct? Okay. And how did you go ahead and find m?
Well, now we can find the gradient because we've got 2 points.
Yep.
So we know for every 2 squares that are run,
Yep.
3 squares are risen. So
Okay. Good.
the gradient's
So
going to be minus 2.
gradient is equal to minus, is it 3 over 2?
Yeah, minus 3 over 2, sorry. Yeah.
3 over 2.
So we've got
Okay, good. So, in this case, the y-intercept made it quite easy, but then he had to sub in, or he didn't even have to sub in points, but he needed to use the gradient to fill in the rest of that for the equation. Now, a line that passes through points 4, negative 5 and b, 1, 3, find the midpoint. Well, the midpoint is like finding the average. So what we can say is the midpoint, we have to add it. There's a formula for it too, but it's actually just finding the average. x1, y1, and this is x2, y2. So the midpoint is we add the x coordinates, x1, y1, x1 plus x2, and we then divide it by 2, and the same thing with y1 and y2. Now, if I add them together, 4 plus 1 is 5. 5 over 2 is, I'm just going to leave that as 5 over 2. But yes, you're right, you could have it as a decimal, 2.5. And minus 5 plus 3 is negative 2. No, yes. And we're dividing by 2, so it's negative 1. That's our answer to our midpoint.
Will we lose marks if we have 2.5?
No, you wouldn't lose marks, but I'd like you to start using fractions. Would be nice. All right, now find the distance of the line segment AB. Now, I guess you could just almost draw a triangle, if you like, with the rise and the run, and that's going to give you the distance, because we're going to use... Who's that guy that said something like a squared plus b squared equals c squared? Yeah, Pythag. Okay, so we're going across... So we're going to be going across a distance of 3, and we're going to be going up a distance of 8. Either way, we just asked to find the distance, so it doesn't matter which way or which way we're going. But so therefore, we can say that the distance is equal to the square root of 8 squared plus 3 squared, which is 64. Is it the square root of 73? Yeah. Yeah, that's it. Square root of 73 units, because we don't know what units it is. Yeah, look, if you then gave me a decimal approximation, that's fine. But if you left it as square root of 73 units, then that's also fine.
You don't have a calculator, so can we just
No, well, you'd have to leave it as that then. Okay. Yep. Find the value... You got a green calculator. Yep. Yeah. You've got the green calculator. Find the value of y. You can't use a CAS though. Not for your tests. You can for your application tasks. Find the value of y when x equals 2. Yeah, I know. We're going to have another little one after this though. Yeah. Find the value of y when x equals 2. Yeah, well, let's just move on to the applications. So we want to wrap this up. What? Find the value of y when x equals 2. Oh, I just want to move on. All right, I might stop there and we'll go through it anyway.